And this started sometime in 2007 when I was in the Department of Science and Technology on deputation. And we tried using this to assess loss due to hailstorms in Haryana. We used satellite data. Thereafter, we started building three-dimensional models using high-resolution satellite data for the security forces for the Central Indian operations. But in 2012, we ran into a problem with Digital Globe, which was the major supplier of very high-resolution satellite data, because they gave us data which was cloudy and they wanted the money for it. We said, unless you change the data, this cannot be used and we will not pay you. It was about $500,000 worth of data for the Northeast. So that is when we started experimenting with drones to fill in the gap for high-resolution satellite data. I think it works from here. Now there are 5 buttons. Which one do you press?
The one, right and left. Right and left.
Okay. Now this is when we first used drones for imaging after the tsunami in the vulnerable coastal areas of Machilipatnam. And you can see its resolution is 2 centimeters and the horizontal accuracy is 5 centimeters and the vertical accuracy is 10 centimeters. So, this is far superior to any resolution that you can get from any satellite, because when you start working with satellite data, the vertical accuracy is 4 times your size of the image. If it is a 0.5 meter image, then you get 2 meter accuracy on the vertical. Therefore, for water management, this is the most effective way of mapping an area if you want to map for water management. Well, this is gone off. This is with a drone. Yeah, this is. Okay. Now, this is another use that we did in Assam, and this was to map the embankment along the Brahmaputra. And we did about 50 kilometers of mapping of this to see the accuracy and the state of the these embankments which have been created along the Brahmaputra. And so it has very wide usages in terms of how do you manage natural disasters and how do you plan for managing natural disasters, because most of your database on the vertical which you get from Survey of India is 10 meters plus minus. So which means that has really no value for mapping and planning for water usage. This is we use this similar sort of data. This is again the Brahmaputra, banks of the Brahmaputra, and to see how vulnerable all these locations are to floods. We haven't been able to get the color, but now what we are doing is the startup that we are mentoring is largely into agriculture. We are working for agriculture insurance companies to work out crop loss, crop area, bifurcation of different types of crop. And this is a plot area which we captured in UP for a sugar mill. Now what we did with this data is you use it with satellite data and then for the reclassification of satellite data. So the accuracy levels that you get are very high. So this is This is the pure drone image, but then when mixed with satellite data, it gives you very high accuracies on crop area, crop loss, etc. This is another work that we did when I was still with the Department of Science and Technology, is to assess what is the extent of tree coverage, the number of trees, the amount of wood that is available in this particular area. So we use drones to assess the capacity and the availability of wood. This is the point cloud model which emerged from that drone flight. This is, again, we use drones to assess damage to crop in Bhid in Maharashtra as a consequence of floods. Now you can work out which are the areas which are affected by floods or heavy rains, and therefore for compensation. And if you use this image over a wider area, when you mix it with the satellite image, you can then assess very accurately where the crop loss has been. Okay. This is what we use this drone data for Odisha. There was a canal to be constructed along with, they were taking out a canal as well as they were increasing the dam height. So now it had to be worked out what is the submergence that would take place to Bodh city, and therefore you needed very high resolution data to work that out. So for various levels. So this is one of the slides for that. This is, we use drones to plan for a power project in Nagaland, in Tuensang. So these are some of the shots that we obtained, again with very high resolution accuracy, so that you can do water management and planning using these data sets. So from the drones, you not only get photographs, but you also get measurements of the ground level, and the accuracy, as you've seen, can be anywhere. The vertical accuracy can be anywhere from 10 centimeters onwards, depending on what your requirement is. And your horizontal accuracy can be 2 to 5 centimeters. This is what we did for the railways to assess their state of infrastructure of the bridges. This is, I think, somewhere in Odisha. This is, again, monitoring railway and power lines using drones. Again, this is for monitoring of power lines. I forget where it was. And this is the Eastern Expressway outside Delhi, which was then under construction. And you can actually work out the extent of earth which has been actually put in there or which has been moved. So the calculations become very very accurate. So this is these are some of the things that we have used for agriculture and infrastructure. Now there's a 3D model. I don't know whether it can work. I don't think it works. We've done this 3D modeling for Shahpura in Rajasthan and for Vijayawada. So you can then actually see the city in 3 dimensions and twist it around and see how to plan or what are the issues involved in urban development. So this is where the use of drone data takes you ahead of any other application that you might have from either satellite or from theodolites or whatever. The accuracy and the quality of outputs that you get. This is, I think, Vijayawada. I think this is Vijayawada, where we did a 3D modeling of the city there. So, and you can then extensively plan your infrastructure and your buildings. I think this is the last slide that we have. So I'll take your leave and just show you how today technology can be used to quickly map and plan. Oh, this is some temple which we flew drones to map and build a model of. I don't know where exactly this is. And there may be one more slide of a 3-dimensional work that we've done. So this is just to show you the possibility of using drones for, this is Shahpura, this is in Rajasthan, and for using drones to actually map resources, plan for water, plan for agriculture, and compensations in case of, the insurance companies, or even trace out low productivity plots, so that instead of giving widespread subsidies for agriculture, then you focus on a specific plot in a particular area or specific set of plots where you need to put in the inputs to increase productivity. I'll end with this. Thank you very much, ladies and gentlemen.